Thanks everyone for being here today. We are excited for this webinar. This is AI Agents in Action, Making Sense of the Magic. I'm Joe O'Neill from Kognitos, and we have two very special guests with us today to lead this webinar. This one, unlike maybe the last two webinars, if we have some frequent visitors here, we're going to dive in a little deeper. And if you wouldn't mind going over to the agenda, I'll give a quick overview of what to expect in today's webinar and kind of set some ground rules for it before we introduce our hosts. So we're going to cover a little bit more about Kognitos' origin story, what led us to today, what was part of the vision that drove kind of how our technology works and what we're looking to achieve in the market. Second is we're going to talk about the specifics and the foundations of the Kognitos brain. Then we'll hit the practical applications of agentic process automation. It's the software category we all care about and that Kognitos drives as a leader in. And then we'll look at a peek under the hood, get some more technical details as to how Kognitos works, how it functions. At any point in time, please ask Q&A questions and submit your questions using the Q&A object there at the bottom of your screen. We'll be answering those questions both throughout, and then we'll have a session at the end where we'll answer them directly. Feel welcome to kind of put that in at any time. We won't be using the polls or raising hands in this particular webinar, but you can feel welcome to do it. And then last but not least, because I know people always want to know and we're happy to provide it, we do record this webinar. It's recording right now, and we'll be providing a link within 24 hours. So without further ado, I would like to introduce our two hosts today, Binny Gill, who's the founder and CEO of Kognitos, along with Matt Strathman, who is our engineering leader, VP of engineering at Kognitos as well. Thank you, Binny and Matt. If you wouldn't mind giving a quick introduction on yourselves, and thanks for doing this today.
Thank you, Joe. Hi, everyone. Thanks for taking the time for joining us. I'm Binny Gill, founder and CEO of Kognitos. I started this company 4.5 years ago to bring in the next generation of programming computers. And with me, I have, actually physically with me, I have Matt Strathman, who joined us as well in this mission. Matt was in a self-driving car company prior to this, and we are trying to build self-driving for businesses as well. Matt, you want to introduce yourself?
Yeah, so as Benny mentioned, come from self-driving most recently, joined up almost a year ago now. Definitely excited to be along on this mission of, kind of changing the interface to computing and really, reshaping business process automation along the way.
Cool. Let me talk about how all this started. We haven't gone into some of the details in the previous webinars that we're going to do in this webinar. All right. Join audio? No. Later. All right. I got some pop-up in the middle. That's exception handling right there. So as what happened right now, I was looking at the Zoom thing and then something popped up. And that was not expected. And being a human, I handled that. Matt also helped me. It's like click on the later button. That is the fundamental difference between humans and machines. Humans are the best exception handling systems out there, whereas machines are the worst. When I was looking at this problem of programming, and I've been a programmer all my life, more than 3 decades, starting with programming languages like BASIC. I did a little bit of assembly as well, not because I loved assembly, it's just because I had a handheld Casio calculator, graphing calculator, where if you programmed in BASIC, it would work, but very slowly. If you programmed in assembly, it would be blazingly fast. So that's the reason I did that. But the jump from assembly to BASIC and Pascal and C, C++, Fortran, all of those things, that was a significant jump. You could see why assembly is like, you don't understand that, but all these other languages, you can actually read and follow. That similar jump actually hasn't happened in the last almost 7 decades of innovation. And during the pandemic, I was seeing this play out in front of me. My son now was trying to learn Python, 12 years of age. I asked him, like, go build some games. And he was like, really, I can build games with programming? I said, yeah, I mean, that's one way you learn. So he went back and came back with tic-tac-toe. This is during the pandemic. I had nothing to do. He had nothing to do. And just sitting at home, And I was looking, and I played it. It was great. Had some issues. So I asked him, like, how did he do it? He said, oh, you know what? I went Googled it and YouTubed it and all of that and stitched together something and it worked. I said, great. And said, you know what? Let's change this color or whatever, right? I mean, I want to make it look nice. It's okay. So he's like, I don't know how to do that, right? Because this is all cut pasted code. And tried a few things. I said, okay, you know what? Here, maybe you can point it. I'm pointing to Python code that was there on the screen on an IDE, I think idle IDE. And as we changed something and it blew up, right? So basically, there's a stack trace and in red color, just because, I don't know, just to scare the person. And a stack trace is like, nobody understands if the first time you're writing a program and you're seeing that stack trace, what do you do? I mean, you're lost, right? So what became apparent to me is that in the last 3 decades, computer science has not really evolved to a point where you're creating a program and then now you're debugging it and troubleshooting it and it's getting easier. So I was trying to understand, is there a different programming paradigm that could be built? And in fact, I realized that it has always existed. We call it human programming, and we don't even call it programming. Think about um, a recipe that grandma wrote. That's a program for another human to follow. And it doesn't crash with a stack trace. If you run out of sugar, you just go to the local grocery store. The program doesn't have to say that. If you look at standard processes in businesses, finance, how do you onboard a new partner, a new vendor? How do you pay an invoice? Or for engineering, how do you check in code? Like these are the 3 steps you follow. First, you get a code review, then you run it through pipeline or Circle CI and all of that, right? So humans are programmable in a very simple fashion. And that program, whenever it has an issue, doesn't crash in a way that's highly opaque, is actually something that the human can understand and actually handle the edge case. Just like, I was handling some edge case here. That kind of platform needed to build. And that's the reason we started Kognitos. The idea was to come up with a paradigm where you specify the process you have in mind in natural language, just like you're writing a recipe for something or a playbook for something. But more importantly, when you have to tweak it and it breaks because of your tweaks, you have control because you can understand what's happening. That's also in natural language. And all your nuances are expressed in natural language rather than some other Python or JavaScript or something like that. So today, if you look at the world, there is a lot of innovation that's happening. We're going from the Gen 2 kind of platforms where you could build automations using RPA tools, but those automations require you to be a developer in order to debug when things go wrong. I mean, you can record your screens and all of that to figure out what is it that you want to do, and the machine will mimic that. But when things go wrong, you're pulling in a developer. This next generation of tools that are coming are defining a new paradigm where even the debugging will happen in natural language. You do not have to look into Python or JavaScript or Java anymore. That is the transition that happened with BASIC and Pascal. You didn't have to look at assembly language anymore in order to debug. That kind of jump is happening after many, many decades, one more time. And therefore, this is a highly significant jump. It's going to change the world. Just like today, how many people are assembly programmers? Only the folks who write compilers, right, and interpreters. They know, and the rest of the folk world doesn't care. The same thing is going to happen with Python or JavaScript. Most of the world wouldn't care. You'd be programming in natural language. And there are 2 kinds of programming you can do. One is ad hoc, and one is repeatable. So ad hoc tasks are, say you want to order a pizza and you just want to order a pizza right now. So you most likely would talk to a chatbot and say, you know what, I want a pizza. It'll give you some options and you go through that. That's an ad hoc task. You just want to reach the end goal. And as long as the goal is reached, you're happy. Then comes processes where the goal is important, but also probably even more important is the steps you use to reach the goal. So for example, what are the steps you follow to create a cup of cappuccino in Starbucks? What are the ingredients to use? How do you do? What machine you use? You get trained on that and you have to follow that exact process. Or what's the process you use to pay somebody for an invoice that comes to your business? Or what are the processes to onboard a new employee, right? So it's not just okay to just onboard the employee, but also the steps you followed, what options you gave, highly important. That kind of world, if you want to solve for that while keeping it that you are using natural language alone, that is something that is hard. That's what we are solving. Kognitos is taking over the burden of solving the problem where you have a process that's repeatable. You can describe it in English, but you want to be able to debug it in English, refine it in English, maintain the whole life cycle in English. So that's what we are working on. If you look at the legacy, and I'm picking UiPath as one example here, but any kind of RPA automation tool, the life cycle of the automation is what makes it very, very complex. You have a studio here where you can create an automation. There's a lot of drag and drop, simple demos. You can easily create it. That's like I talk to a developer and say, hey, create me tic-tac-toe. Just the starting point will be fairly easy. But if I have to go and test it out with all different scenarios, all different inputs. What if the user puts in, instead of X, puts in a Y or something? Like there's all sorts of edge cases that could be very strange. So you need to use so many tools to test your automations. Imagine if you're doing document processing. For the 10 documents that somebody gave you, you tested your automation, it works. The 11th document comes and it's a completely new document, or maybe somebody sent the picture of their dog by mistake. Now that the whole thing crashes, and you're like, oh, I think I should put in another if then else, another branch in my whole thing workflow that it will take care of that scenario. The reality is that in the real world, the number of edge cases are infinite. And that's why software never finishes. Software never is complete. Oracle database still isn't complete today after decades of writing code, but my grandma's recipe has been complete for decades. And the reason is the architecture of the execution engine is different. It's not that the language had a problem. The execution engine is requiring you to go do these DevOps lifecycle and maintain this over time. And the more you use this life cycle, the more complex your automation becomes, and the more you have to invest. And it eventually just becomes so bloated that it falls apart. And that is what has happened in the entire RPA space. There was initial excitement, and now it becomes too big to maintain, and people are saying, I don't want to grow this anymore. And that's why RPA is struggling. We have to rethink this whole architecture. This is what we have seen. Before RPA, people were doing homegrown custom applications to avoid manual work. RPA came in and rescued a lot of these very simple tasks. The tasks that don't have too many variations, so they don't bloat over time, RPA was great. But as people started looking at RPA to handle more edge cases and more end-to-end cases, it became really complicated. So that it kind of struggled and didn't go beyond what it did last 3-4 years, had been quite stagnant. Now comes AI that opens up a new avenue of handling these variations in edge cases. And the trick is to do it with the same guarantees that RPA provided. What were the guarantees that RPA provided? RPA never hallucinated, never had a bias. It would be brittle for sure, but it would never go do something that was not pre-approved by a business. AI has a high risk. While it is flexible that it can handle all these weird cases by guessing its way forward, it might also end up doing something you never intended. And this is where finance and accounting, legal, HR, are very, very about how do I use AI in a way where I can get ROI, but I'm also not taking too much risk, right? So that's the place where what is really required is a combination of the flexibility of AI with the deterministic behavior of quote unquote programming. You're still programming, but you're programming in natural language. You're giving instructions step by step. That is what we are doing. So we're going beyond the initial crop of AI agents. Those are the ad hoc agents where you don't really understand how the AI is going to do it, but you're very happy and surprised that it actually did what you wanted. But we are going and saying, look, the goal is, of course, important, but transparency on all the steps, and then, making sure that you can tweak the steps over time, make it nuanced in a way that you want. That is important. That's what we are providing in the Kognitos platform. That reduces the risk quite a lot. The human is in control. These are agents that follow process. And that is probably the most important thing in delivering ROI to businesses today. You bring automation using AI to the most important processes of the business. And those most important processes have documented steps for humans to follow. AI must follow the same steps as if AI was employees. They'll follow the same steps. And what are the pillars that we believe in? AI should never override a process unilaterally. Just like I expect no employee should override, even though they're very smart, they should not override. They must ask the manager, hey, I'm going to not follow this step because XYZ. AI should behave the same way. On our platform, we make sure that happens. AI must have truthful memory of what happened and why, both like transparency of what happened, but also why did you make a decision? Because unless I understand the why, I cannot refine the behavior. So that part is only possible if it's a platform where you can see the logic, right? The logic should not be a black box within an LLM's head. Thirdly, very important in pragmatic business environments is if AI happened to do something wrong or the agent did something wrong, we should be able to go back and tell the agent, you know what, that thing, rewind your state of mind, go back to that previous step with this new data, now fix what you did wrong. So it can also do that. Extremely important. This is Matt will talk about. We have like a time machine for this and all of that. So we can go as deep as you want in this session. Joe has told me we have the license to go and geek it out. We might do that. And then finally, being able to learn, which AI is like we always know AI learns, but what about unlearning? Has anybody told you about how AI can unlearn? That is very, very important in businesses. Businesses do change strategy, right? Today there is tariff, tomorrow there is no tariff. So you have to learn and then you have to unlearn at the flip of a switch. Can AI do that? If not, you have a business that is sort of very, driven by habit. You don't want a business that's driven by habit. You want a business that's driven by the logic that is provided by somebody. So all of those things, how we do that magic, we have the man here, Matt, with us. We'll talk about it. Matt.
Cool. Thanks for handing it over. Yeah, as Binny mentioned, automation is changing, right now, and it's changing dramatically. And it's no longer just about executing tasks. It's about orchestrating intelligent agents that can adapt, learn, and optimize business processes seamlessly. And Kognitos is revolutionizing the enterprise automation by introducing an kind of advanced operating system that not only manages agents, but also empowers them to operate with intelligence and precision. Now let's kind of dive deep into some of these aspects. And Binny was already kind of alluding to some of these in the last slide of how this works. So just like organizations rely on standard operating procedures to ensure consistency, Kognitos Brain allows businesses to develop processes and skills that execute with determinism to achieve business goals consistently, and that's really important. And then, over time, we're building up this flawless memory, which is a key differentiator for Kognitos. And every step, every input, every output is recorded. ensuring a complete recall of the entire process execution. This enhances traceability, accuracy, reliability, while maintaining a strong audit trail of your process execution. So I'm still going here. Yeah. The other benefit of this system, as Binny was pointing out there, is that you get almost this time machine effect where processes can be restarted from any point, enabling exploration of alternate execution paths dynamically. And kind of intelligent escalation is built in on the belief that automation should be adaptable, not rigid. When a process encounters uncertainty or an exception, Kognitos doesn't fail. It intelligently escalates, whether through large language models or human intervention. The system seamlessly integrates guidance, ensuring processes reach completion while continuously learning and improving. Kind of beyond intelligence, Kognitos is built on this cloud-native infrastructure, allowing it to scale dynamically based on the workload's demands. This ensures efficiency and adaptability to business needs. So maybe next slide. Yeah, so here we introduce the concept of HAL, the hyperautomation lifecycle, where AI is transforming the automation landscape, but traditional automation approaches often fall short, requiring constant maintenance, manual intervention, and lead to fragmentation of processes. So Kognitos is solving this with the hyperautomation lifecycle, or HAL, which turns simple instructions into smart self-maintaining AI agents. The Kognitos brain architecture introduced in the previous slide makes this capability possible by leveraging that foundation of SOPs, processes and skills that constrain the execution, the guidance that's coming in from humans, as well as this execution engine that has that time machine quality, as well as the flawless memory and intelligent escalation path rather that's built into the platform. And then this provides us the ability to construct this HAL experience, which leads to genuinely effortless automation. At the heart of HAL is this AI-driven automation where AI participates in every step of the automation lifecycle. Instead of organizations struggling with script maintenance or debugging, Kognitos enables a seamless, self-sustaining automation process through 5 key capabilities of the lifecycle here, which is auto write, where AI translates the natural language instructions into automation; auto test, where the system intelligently validates the automations; auto deploy, where once tested, the automations are deployed effortlessly; and auto monitor, where HAL continuously observes the automation execution, and detects anomalies, ensuring smooth operation. And then finally, auto debugging, where issues arise in Kognitos, we can diagnose and resolve those problems, reducing time, downtime, and eliminating, kind of that tedious troubleshooting effort. So this hyperautomation lifecycle is a fundamental pillar of the value that Kognitos is delivering, and is built on a trusted AI system of record, ensuring that transparency, that reliability, that compliance at every step. So now let's go deeper into each of these components. So we'll start with auto write. We believe that automation should be as simple as describing a process in natural language, as Binny was pointing out earlier. This is really key to the mission that we're on. And auto write makes this possible by transforming SOPs into fully functional automations, eliminating the need for complex coding and technical expertise. So how that works is, we take that SOP to automation, by in the auto write workflow, using proprietary LLMs, converting that process to that automation. And then this is achieved using your agentic AI team under the hood, composed of the architect and the developer. The architect interprets the SOP and converts it into a high level plan, and then the developer then translates that high level plan into a detailed set of execution instructions ready to run on the Kognitos brain. If any errors arise in that development process, then the developer is there to assist in debugging. So we were talking about the architect and the developer, and then how this works is there's it's an interactive session where users can refine and adjust the automation in an intuitive environment to ensure that it aligns perfectly with their needs. And this can be done either by interacting with your AI agent counterparts through natural language in a chat interface, or it can be directly editing the plan that's been produced for execution. So really what this enables is that if you have an SOP, then you can have an automation, and auto-write enables kind of enterprises to accelerate automation adoption, unlocking that immediate ROI while reducing the technical overhead traditionally required to do that. So on to test. So once an automation is written, the next critical step is ensuring that it continues to function. And do that reliably over time. And auto test enables organizations to avoid regressions in production by leveraging AI-driven automation testing based on that flawless memory of past execution history. The auto test continuously evaluates automation performance based on prior experience, identifying potential failures before they impact operations. And unlike traditional testing approaches, Autotest eliminates the need to manually create test cases. Instead, it intelligently identifies the most relevant test scenarios based on real-world execution and adds those test cases to a regression test suite. Whenever a process is modified, then Autotest quickly determines if the changes break any previous functionality and provide immediate feedback on potential risks and guard your production from those regressions. So with Autotest, organizations gain confidence in their automation, ensuring that the changes that they're making can be done quickly and safely without disrupting business operations.
Yeah, so thanks, Ashley, for adding your question on the question and answer tab. So Ashley is asking a question around, in general, when the SOPs are evaluated, is there an opportunity for optimizing the business process itself? And also there could be some system limitations and working around those limitations, as well as there's a high demand for clean data based on SOP. Is always assuming things to be perfect. I mean, so I think I'll answer based on what I understand the question is. I think we are hitting on the right questions here. So standard operating procedures are basically standard for a reason, but in reality, when a business is running, not 100% of it is actually standard, right? And then there is also reality on the ground keeps on changing. So there is some amount of deviation from standard that keeps on happening when humans are running it. And that's why it's very hard to take what humans are doing and translate it into automation using traditional methodologies. Because you have to, first of all, discover everything that the humans are doing, all the variations, and you do process mining and discovery. But you know what? Humans are capable of doing infinite things to handle edge cases. So that itself is very expensive. So the way it works is, you go back in the slides a bit. So the first step is, once there is an SOP, there's an architect here that's looking at the SOP and asking questions to the user about what do you want? If there are multiple ways of doing things, what do you want? The architect also here is aware of the backend capabilities that the system has. And on our platform, you'll see we call them books, which have credentials and test and production environment and all that. And each book is a collection of micro skills. So based on the skills available, and those are the limitations of what's available, And based on the SOP and question answer with the user, the agent is trying to come up with a plan of execution, which, by the way, may not be complete and perfect, but that's not the goal. The goal is to get to a point where it is decent enough that it could do 90% of your work for you. And the remaining 10%, it'll pull in a human and say, hey, this one, nobody told me. Can you please help me? The reason we can pull in a human is because this is all natural language, and the human knows where the automation was and what it can do, right? So I hope I answered the question here. There's also another question, Matt, if you want to look at that. How do we support applications on premises?
Yeah, so we'll go over a little bit of that later. I mean, we definitely have the ability to connect through VPN to our cloud infrastructure. We can do, various levels of isolation for, different tenants in the cloud as well. We don't yet make an offering that we deploy on premise, though the architecture supports it. So it's something that we will support in the future. It's just a choice that we have made to not add that complexity right now.
Yeah. So let's talk about deployment. Right?
Yeah. So the next step after testing is deployment. So deploying an automation into production can often be a complex and resource intensive process. Auto deploy removes these barriers, ensuring a seamless and scalable deployment experience. Auto deploy is built on a serverless cloud architecture, eliminating the need to manage the bots or virtual machines while ensuring scalability and cost efficiency. It's designed for enterprise-grade deployments where auto deploy maintains a strict separation between testing and production environments. We call them draft and published. Reducing the risk, supporting compliance, and enhancing stability. The system automates the transition from test to production, replacing old versions with newly validated releases, ensuring reliability and reducing any kind of downtime. The auto deploy integrates seamlessly with your private cloud environments, your VPNs, and offers the ability to deploy private LLMs, and that provides the flexibility that organizations are looking for. So hopefully that addresses some of the questions. I know that we preempted that a little bit, but with auto deploy, the enterprise can really achieve continuous delivery and scalability without the burden of infrastructure and management. And we help accelerate that time to value. So next is Auto Monitor, where automation doesn't end at deployment. In a lot of ways, that's kind of the beginning. It requires continuous monitoring to ensure resilience and reliability. Auto Monitor provides real-time oversight of every automation process, capturing insights and escalating issues when necessary. Every step of the automation process is recorded, as we've mentioned, and monitored in natural language. And this ensures transparency and accessibility, all along creating that flawless memory of each process execution. Auto Monitor detects anomalies in execution and escalates them to a human for intervention when necessary, and the system learns from the human feedback over time, and that makes the automations more independent and adaptive every iteration. And then by integrating auto monitoring, these organizations can ensure that their automation remains resilient and adaptable and continuously improving, giving them the tools to tame that, even those most unpredictable edge cases that will arise.
How about debugging?
Debugging. This is where all the time goes. This is where most time consuming and costly aspects of automation are really this debugging portion. Auto debugging is meant and does seamlessly kind of integrate and with the processes and proactively identify issues and suggest solutions, and it can be uses that past execution data for efficient problem resolution. The auto debug pinpoints anomalies and identifies the root cause of the failures, reducing that time spent in manual troubleshooting, trying to figure out where the issue has happened. It can draw on that those insights and service them with solutions. The system kind of proposes corrective action that can be directly applied in auto write, accelerating that time to resolution, as well as we have the auto debug using the auto monitoring recorded steps and values to understand why the execution deviated from the expected outcomes, and makes the debugging experience more precise. And then by minimizing downtime and reducing manual debugging efforts, auto debugs, obviously significantly lowers the cost for maintaining automations at scale. So that's kind of the gamut of all the 5 phases of the life cycle.
Okay, do we have a demo?
We do indeed have a demo.
So why don't you set that up?
Yep.
Yeah, I just talk about this auto debug thing is extremely important to bringing the desired ROI to automate any kind of automation. Because if you look at the traditional way of writing software and debugging software or writing automations using RPA, the real challenge is around when things go bad, they go wrong. Who am I pulling in to figure out what went wrong and then after that fix the problem? If you're pulling in somebody who is either an RPA developer or a Java Python developer or shell script developer, or you're pulling in a prompt engineer, or you're pulling in a data scientist, you have a problem. Because all these resources are rare, expensive. Ideally, if you're really truly mimicking human behavior, and the AI agent should act like an intern, and the intern should pull in the manager or another employee, a coworker, like, hey, can you please help me? And that coworker is somebody who knows how to do that thing, the process manually. They're not an IT person. They're not somebody who knows computer language or programming, but they do understand the language of the business. What does the VP of finance want to be done in that particular scenario? Or what does the head of, by sales or HR or legal want to be done? So that is the hardest part. And what we are able to do with our platform is, because our platform is a one-stop shop for all the aspects in the life cycle of the programming and the automation, it is able to debug in a way that other platforms today cannot do, right? Whether you're using a cursor for building your automations today, or using PyCharm, or you're using Replit or whatever. Our system is powerful because it also has a time machine, a flawless memory of what has happened. So AI with the right data is able to deliver a better root cause analysis of what happened and therefore help you fix the problem. So maybe in the demo, you'll also see some things. You want to share your screen?
Yep. Let's do it. Share screen. Where's the demo? There it is. All right. Can people see that? Is it coming up? There we go. Cool. So this is the Kognitos platform. If folks haven't seen it yet, we're on the process page. We're going to be focusing on the process and invoice process today. What this process does, relatively simple, and what this demo will show you is, we're focusing on the deployment area. We've kind of touched on other parts of the HAL lifecycle in the past, in past webinars. We've never really gone into any aspects of the deployment and infrastructure before, so we'll talk about that today, where we have a process, we published it, we want to demonstrate this, the scalability aspects and the effortless scaling today of operating your process. So what we'll do here is, we'll kick off many processes in parallel effortlessly and see the platform scale and execute this process in parallel. So what this process does is it takes in a document and it conducts OCR. I'll kick it off right now, and then we can watch it run in a second. So it scans the document through an OCR system, and then it does some extraction from that. So we're going to pull out the vendor name, we're going to pull out the subtotal from the document, and then we're going to get all the itemized values from the invoice. And then what we'll do is we're just going to do one validation on this invoice, but you can imagine, you could do many validations on it. We'll just check to see that the subtotal matches what the items totaled to in the itemized table. And then if there's a discrepancy, then we'll send an email to me, and I will review that invoice and figure out what went wrong. So to view the runs that are going on now. So I kicked them off screen there a second ago. You can see that there's all these runs that are running in the background now, kind of effortlessly scaling the platform and handling all of those processing in parallel. You can see that, we have the document come in here. It's, a fairly, I'm going to move my zoom here for a second, straightforward document to process. An invoice that has this itemized table that I talked about. The vendor name is up here in the vendor details, and then the subtotal right here. And then we'll go back to the process. So the OCR is taking a little bit of time today, unfortunately. But once we progress through there, then we would, see the remaining processing of the document here, where we've extracted the fields from the document, and we are doing the comparison here at the bottom. This one had no discrepancy with a 0 return value, and then you can also inspect all the runs as they come in as well, with all the values being populated here. You can see in this view the the subtotal and the computed total as well, that we're tracking as interesting facts in the system. And then we can go in if we wanted to add more facts, like maybe we cared about that difference in this view to see which ones may be more interesting.
What are the current columns that it is showing?
The current columns are the subtotal, the computed total. Yeah.
So here, so there's the subtotal and the total sum.
Yep.
And where are they on the run? So if you can take us to a sample run,
Yep.
which has already completed.
Oops.
So, okay, so this is one thing I was saying, is like it has flawless memory. So not only it has completed this run, or this one, it's actually, you can go back and query it with everything that it has done in the past, and you can see the details, not only the logic in natural language, what it did, but also the values and what it did. And you can ask for more details. So like here, there are 2 stars, orange stars, which say these are the things that I feel are important in this entire process. And the moment you start it, it should be available now in all the reports around this kind of process that you have.
So everything else is completed at this point. So let's go back. Oops, I meant to go back to the table. So yeah, now you can see all the differences as well. So that makes it easier to highlight, where there's a discrepancy. We can click on, one of those runs and see that did indeed email me. You can see the emails did arrive in my inbox here. We can click on one of those. It shows up with, my fairly generic message, but, gives me the information, and you could enrich this certainly.
So what did we do here? So you had a bunch of invoices, and you wanted to find out which ones have a discrepancy between the subtotal and the total.
Correct.
Right? They should match, and if they don't match, you get an email. But also, if you want to go and dig deeper, then you can look at a run and precisely see what the events were. Right? So this is basically the power of having an intermediate layer of reviewability for a business user. Now, this isn't Python. If this was implemented in Python or UiPath or something, only a developer would be able to tell you, hey, this is what happened. If you're going to challenge what the automation did, if you are happy with everything, that's fine. So always, the good case is always, nobody complains. The real question is when something is being questioned or something is wrong, who do you bring in to troubleshoot? And who do you bring in to answer your questions? If it can be done by anybody in the business, now you have a democratic solution which will be adopted much faster. And also the worry that people have, oh, there is this one edge case where I don't know whether I have solved it, will be much lower because it's not by automating, you're not taking away control from people. The same kind of thought process is what goes in people's minds with self-driving cars without steering wheels. By automating it, are you taking away my control? If yes, I'm a bit worried about it. But if you're automating it while giving me a steering wheel, then it's okay. It's my decision whether I want to use it in self-drive or not. So that's the philosophy we have in terms of bringing in AI-based automation to businesses where it's mission critical to not only get things right without bias hallucination, but also prove to a business user that that's what happened and allow them to edit it, change it however they want.
Yep. Very powerful.
Are there any other questions, Joe, that we haven't yet answered? I've seen that you've been answering them.
Yeah, no problem. We had another good question. Maybe I'll just cite it, and you guys can answer on your own. So, more like self-improvement AI, where it can use memory of the past and our platform's dry run regression testing capability to prove to the business user that the new behavior is strictly better than the old behavior. Sounds like this is more like long-term contextual memory storage, similar to a human long-term memory. Is that right?
Actually, you're 100% right, but that's also the inspiration, right? So when we started Kognitos, we wanted to mimic how the human brain works, and not necessarily how 7 decades of computer science has forced us to think as programmers, but with one minor change. And this is one analogy I give people, like, so human mind makes decisions emotionally, right? That is okay as long as another human is making that decision emotionally. It is not okay if AI makes decisions emotionally, because we do not think that AI has the right to make decisions emotionally, right? Humans want the control themselves. So I would say what we wanted to build is, if you are familiar with the old Star Trek series, there was Captain Kirk, that's the human, is emotional, makes the decisions, but there's also Spock, who's a Vulcan, who makes decisions logically, is able to understand English and negotiate in English and follow process. Spock or Data, right? I mean, those are the things. So for humans, machines should be more like Spock and Data, able to understand what we are saying and follow our process and not be emotional, because that's not what we would want to delegate to a machine. That's the only difference. But in terms of contextual data and all of that, yes. Therefore, we talk about not contextual data and RAG, we talk about flawless memory. It's because it isn't okay to be 99.9% accurate. We have to be 100% accurate if you're applying it to your business finances, right? So that's the guarantee we want to do. There you go. Ashley is a Trekkie, so good. That landed. Awesome.
Benny, would you extend that further too into the concept of like the storage of tribal knowledge? Because I know we've heard that from some customers as well.
Yeah. So what we are actually trying to do is to extract tribal knowledge from people's minds into a system of record. And this system of record, instead of being very burdensome and let's put recording devices in everybody's laptops and do process mining and discovery, this system of record collection is actually natural. You just first say, explain your happy path. And then that's your happy path. Even a VP or somebody who has written down the standard process for the company will be able to tell you that. Now there is this infinite set of edge cases that are there in the business. The system, by talking to the people who do things manually, will gather that information over time. Now they have the option. They can say, you know what, this one, I'm just going to do it. Don't worry. Thank you for helping with the remaining 80 out of 100. Or they could say, you know what, let me give you guidance. So we call it guidance. They give guidance to the system records it and collects all the guidance from the humans. And that is how we are sort of documenting tribal knowledge, because a business at the end is actually a collection of business processes that stay there, and the employees come and go. And the same logic has to be applied to AI. Business is a collection of the processes, not collection of AI agents. The AI agents are there to follow the process and maybe help humans refine the process, but the process is what defines the business. And that is extremely important. We should not lose sight of that. Oh, one more question. How do you prevent human error? Example is an experienced person in the loop, but is on vacation, new person comes in, and what happens? How do you prevent human error? The answer is you don't worry about that, because see, to err is human, and to err is also AI, because AI is mimicking human, right? What my point is that society is okay with humans making mistakes, and our society is not okay with AI making mistakes that have grave impact on humans, right? So because we are human, we know that another human might make mistakes. So first strike, second strike, third strike, you're fired. That's okay. That's what businesses want, that at the end of the day, they can hold a human accountable and give them tools that make them uh, be able to do lesser mistakes. So a tool that is more white box gives them control, gives them ability to audit, approve before something happens. That's what we want to provide. But at the end of the day, mistakes will happen. But the goal is that whenever a mistake happens, you have a human responsible for it, and that makes business function well, versus being stuck with, oh, we bet on this AI agent, now it made a mistake. What do we do? Do we fire the AI agent, or do we get an AI PhD to come and refine the agent? I mean, right. Those things are much harder to actually make work in a business. Another question, do you want to take an answer?
What do we got? Didn't see it.
Oh, do we need 2-3 tier landscape for dev test production landscapes to deploy Kognitos?
Do we need tiering? Yeah, I mean, it's built into the product in essence, right? So the dev test environments are native to the product. We call them draft and published. So you have different credentials, you have different fully isolated environments within the product. All of the testing and validation happens in draft, and that's what gives you the ability to confidently move things into production. And that has kind of, it makes it seamless for that transition as well. So all of the deployment aspects of that are built into the movement of a item from draft to publish. So you don't need the traditional dev test. You have it built into the product natively.
Yeah. Awesome. So yeah, just a couple more slides. I'm still trying to see how I can share it properly, but maybe this is fine. The dev test production is built into our platform. It is still optional, but where we are applying is places where there's high return on investment. And those places typically are where they are really worried about, have you tested it? Have you deployed it properly? So yeah, we do have all those stages. And most of the places where our customers are using us, they use that proper life cycle. Our platform makes it super easy. I mean, it's like a simple AI assists with every phase, but still the control is with a human to say, okay, it's Saturday morning, I'm okay pushing it out to production. And it's up to the human to decide when to do it, when not to do it, and also what changes they want to make. The system will give a report of, this is the testing, this has matched, this is not matched. It's up to the human to decide, is it good enough for their business? How much risk do they want to take? It's all humans' decision. And once you give that power to a human, then they are more comfortable pushing it into production, and that leads to ROI with our platform. There are few examples here how we have been able to solve a bunch of different use cases for our customers in different verticals and different departments in an organization. On our website, you can find a lot more as well. Joe, you want to take over?
Yeah, thank you so much, Benny. Thank you very much, Matt. Great stuff today. I think just for everyone who's attended, there are three basic things that I want to kind of direct you to based on your specific needs and how we can work together. The first things first is if you think this is something that can work in your organization, maybe you're transitioning from RPA, maybe you're a developer yourself, and you want a quick win, you want to see how Cognitos can help satisfy a use case or a direct need that you have, absolutely reach out to us. We can schedule a personalized demo. We can examine your use case really closely, build a business case, build a test. Certainly all those avenues are available to you, and you can reach out to sales@cognitos.com and we'll get you set up right away. In addition to that, we've released a community version of Cognitos that actually has many of the skills built into it today that Matt shared in his demo. You can sign up for that free trial and test it today, going to cognitos.com and clicking on that free trial button. That'll get you right into testing HAL. And then last but certainly not least is we conduct these webinars monthly, sometimes every other week or so. Always looking for great ideas, things you want to hear about, things you want to dive. Maybe you saw a nugget of it today and you want a little bit more information, and we could spend another half hour, 45 minutes diving into that topic in particular. Email me, send it over to joe@cognitos.com. And yeah, we'll put it on the calendar and get going. But I want to thank everyone for coming here. Thanks again to Binny and Matt for the great presentation today. And we hope to talk to you all soon. Take care.
Thank you, guys.
Great, thanks.
Take care. Bye.